Refresh your browser to make sure the course server is running, or restart the server in Terminal. Continue with your project from episode 3, or open the starter project for this episode. Build and run. In episode 3, you used Swift Concurrency to fetch this list of available stock symbols. You called available symbols in Symbol List View. The app needs to do this only once. So you called available symbols only if symbols is empty. In the simulator, select the stock symbol and click Live Ticker. This screen needs to display the selected stock symbols and what appears to be a live feed of stock prices. Stop the run. Go to Little John model and locate Start Ticker. You need to add code to this method to fetch a continuous sequence of values from the server. In fact, you'll fetch an asynchronous sequence, which lets you iterate over its elements asynchronously as more elements become available over time. You'll learn more about asynchronous sequences in episode 9. First, go to Ticker View and call Start Ticker. Scroll down to the to-do below padding and add this code. This is the same task do catch code block you used to call available symbols in Symbol List View, but here you don't have to check for existing values. Also, Start Ticker doesn't return a result. Ticker View handles continuous updates, not a single return value. Now go back to Little John model to make Start Ticker work. Like available symbols, Start Ticker creates a server endpoint in a guard throw statement. It doesn't return anything. Scroll up to the declaration of ticker symbols. Start Ticker will store what it fetches in ticker symbols. Like available symbols, the next step is to call an async URL session method. After the guard statement, add this line. Bytes from returns an asynchronous sequence instead of a data instance, and you store this in stream. Live URL session is a custom session defined here. It makes requests that never expire or time out, so the app can keep receiving from the server indefinitely. Unlike when you fetched the stock symbols list, you can't wait for the request to complete and only then display the data. The data must keep coming in indefinitely, so the app can keep updating prices. The server will send you a single, long-living response, adding more and more text to it over time. Next, in Start Ticker, check the URL response status code. This is the same status code check as in available symbols. And now comes the best part. Add this for loop. Stream is a sequence of bytes from the server. Lines is an abstraction of this sequence, an async line sequence that gives you lines of text one by one. You print each line in the console to see what it looks like. Spoiler, JSON. So you'll iterate over lines and JSON decode each line. Now add this code in the for loop. Now you're all set. Build and run. Select a few stock symbols and tap Live Ticker. In the console, you see that each line of text is a complete JSON array. It works, but there are warnings interspersed and also purple warnings next to ticker symbols equals empty array and ticker symbols equals sorted symbols. You probably know what's wrong. You might have been feeling a little uneasy all this time because setting ticker symbols updates the UI, and you're used to dispatching UI updates to the main queue. And yes, the purple errors come from the main thread checker, which is enabled in Xcode by default. But over in Symbol List View, you called available symbols. Why didn't you get this error there? This line of code is in a Swift UI view, updating a state property, and Swift UI makes sure updates happen on the main thread. Back in Little John model, you're updating the published property ticker symbols in an asynchronous context, which usually runs on a background thread. Fortunately, Swift Concurrency has a solution for this. Wrap the ticker symbols lines in some code. You remember main actor from episode 2? It's a type that runs code only on the main thread. In the next course, Beyond the Basics, you'll create other actors to make your objects thread safe. To help you check your updates are coming through, add a print statement. Build and run again. Select the stock symbol and tap Live Ticker. Everything's working now. There's just one last detail to handle. Don't stop the simulator, just keep the app running. First, a word about structured concurrency. Click back to Ticker View. This task modifier in Ticker View calls start ticker asynchronously. Jump to the definition of start ticker. This is the top of a task hierarchy because start ticker asynchronously awaits URL session.bytes, which returns an async line sequence that you iterate over. At each suspension point, that is, every time you see the await keyword, the thread could change. Go back to Ticker View. Since you start the entire process inside this task modifier, this async task is the parent of all those other tasks, regardless of their execution thread or suspension state. The task view modifier takes care of canceling your asynchronous code when its view goes away. Thanks to structured concurrency, all asynchronous tasks are also canceled when the user navigates out of this screen. Make sure your Xcode console is open and keep an eye on it while you tap the back button in the simulator. Ticker View disappears and the task view modifier's task is canceled. This cancels all child tasks, including the call to start ticker. As a result, the debug logs in the console stop as well, verifying that all execution ends. However, Swift UI doesn't like that your code is trying to present an alert after you dismiss the ticker view. Like Symbol List View, Ticker View also shows an alert when its last error message property changes. And when the runtime cancels the call to start ticker, the ongoing URL session that's fetching the live updates throws a URL error. You don't want to set last error message to this URL error, so you need to handle this cancellation error specially. Scroll back down to the task modifier and insert this code in the catch closure. The URL Session API throws custom errors and has a dedicated cancellation error code. Other asynchronous APIs throw a cancellation error. Here you catch the URL Session cancellation error and don't set last error message. Build and run. Select some stocks. Tap Live Ticker. And tap Back. Now there's no runtime warning. Congratulations, you've completed the first project in this course. The next episode challenges you to handle one more error. What if the server stops while you're in the live ticker view? You finished part 1 of this course. Great work! To build your first asynchronous app, you took a quick look at some of the main features of Swift concurrency. Using async await, you fetched a list of stock symbols from the course server. And then you got a never-ending async sequence of price updates for the stock prices. You learned how to use the task view modifier to call an asynchronous method from a Swift UI view and how to run your view updates on the main thread with main actor. You even got some practice with handling errors. In part 2 of this course, you'll work on another app, Superstorage. It's a cloud file storage app with 3 download plans. You get a more detailed look at async await, async sequence, and main actor. You'll use a top-level asynchronous task to call an asynchronous method from a Swift UI view. You'll learn the async let syntax for grouping asynchronous tasks so they run at the same time. You'll use a download stream iterator to process async sequence bytes. You'll get more practice canceling tasks, and you'll even integrate a combined publisher into your app. See you soon. Welcome back to our course, Modern Concurrency. In part 1, you've learned some basic ways to integrate asynchronous code into your apps. You're getting comfortable calling and writing async functions and iterating over asynchronous sequences. In part 2, you'll implement Superstorage, a cloud file storage app with 3 download plans. Silver just downloads the file. Gold downloads the file in chunks and displays download progress. And Cloud 9 downloads the file in 4 concurrent tasks. Superstorage uses async await and async sequence. You'll also learn the async let syntax for grouping asynchronous tasks so they run at the same time. You'll use the top-level asynchronous task to call an asynchronous method from a Swift UI view. And you'll learn a different way to run code on main actor. You get more practice canceling tasks, including a task hierarchy with child tasks. You use a download stream iterator to process partial downloads, and a local task property to display partial JPEG files. You'll even integrate a combined timer publisher into your app to show the download duration. A combined publisher can asynchronously emit 0, 1, or more values. It can optionally complete with a success or a failure, just like an async sequence. Let's get to work.